Okay, in this next part, we're going to be doing a few more questions. So the first question is to solve the inequality x squared minus 3x minus 10 is more than or equal to 0. So the first step is to factor that because that is a quadratic. X squared minus 3x minus 10 is more than or equal to, is it greater than or equal to 0. So basically, again, we just start out with our two x's and then we find a number that multiplies to be negative 10 and adds up to be negative 3. So if we multiply negative 5 and 2, we get negative 10. And if we take 2 minus negative 5, that gives us negative 3. So those are our two factors. And then we go ahead and we start our number line thing that we've done before in the first exam. So I started with my first factor, which is x plus 2. And so I put the point negative 2 because in the situation where x plus 2 equals 0, x is negative 2. So I put the point x negative 2 on the number line, and then anything more than that will be positive, anything less than that will be negative. And then I'm just going to do the same thing, but for the next factor, x minus 5. So here's my number line for x minus 5. And again, I've plotted 5 because when x minus 5 is equal to 0, x is 5. So I've plotted 5. Anything more than that will be positive. Anything less than that will be negative. And then you just make another line that involves both of those factors. So I brought down the negative 2, I brought down the 5, and a positive and a positive is a positive. A positive and a negative is a negative, right? So anything between negative 2 and 5 is going to be negative. And then a negative and a negative is a positive. So all in all, we have anything from infinity or negative infinity to negative 2 is going to be positive. Between negative 2 and 5, we have negative, and then, or below the x-axis, and then anything above 5 is going to be positive. 5 to infinity. So we just went ahead and wrote that in interval notation. So remember to make an open parentheses for your infinities because there's no such thing as including infinity because it's not really a number. And then you have to do a close bracket for 2, for negative 2 and 5 because we want to show that we're going to include negative 2 and 5. If you go back to the question, he said, solve the inequality where this is more than or equal to. So you need to include the part where it is equal to 0. And it is equal to 0 at negative 2 and 5. That's the zeros of our equation. So you must include negative 2 and 5 in your brackets. You must show that negative 2 and 5 are part of the solutions, okay? And then that's basically that. Now, next I wanted to go over some like log and exponent based questions. Really more log because you're definitely going to be seeing these on your exam. So I have three different questions. They're pretty short. So for the first question, um, it's e to x to the x squared plus x equals e to the 12. So here, if you just raise each side of the equation to a natural log, then the natural log and the e's can cancel out, right? So that's a strategic way to work with this. So I took both sides and I rose them to a natural log. So it's natural log to the e of x squared plus x, a natural log to the e to the 12, kind of. And so what happens is that I can cancel out the natural logs and e's on both sides. And what we end up with is we end up with everything gone, all those natural logs and e's, and we just have x squared plus x equals 12. Now that is a quadratic. So I rewrote it here, x squared plus x minus 12 is 0. And then I went ahead and solved that, so we have x plus 4 and x minus 3 if you work that out. So negative 3 times 4 is negative 12, and then 4 minus 3 is just positive 1. So those are our two factors. And then once you found your factors, you need to figure out what the x's are. So the x's are negative 3, and the other x is, the x is 3 and negative 4. So I just wrote those here at the top. And then moving on to our next one, it says that log base 5 of 1/5 is x. So there's a couple of interesting rules we're going to be utilizing in this question, and I'll show you them. So the first rule is what I've drawn in this square that says that log base b and to a number is equal to x, you can just take the b and then put the x in the exponent, and that'll equal the number that was here. So using this rule, we can basically take that 5, raise it to the x, 5 to the x, equals the number that was here, right? So 5 to the x equals 1/5. And this is a rule that you definitely have to know for the exam and keep in mind because it'll probably come up. Now, after that, we basically need to figure out what this x is right here. So 5 to the x is 1/2. So what is x? Well, there's another rule here. X to the negative 1 is 1 over x. So basically, if you have something in denominator, you can just write it up here, but with a negative exponent. So over here, I have basically 5 to the negative 1 is equal to 1 over 5. So x is just negative 1. Now, these are two really important rules to know. There are about 8 rules in all to do with exponents and logs. So it's really important to know those, and these are just some very important ones. So I labeled them. This is rule number 1 that goes with this one, and this is rule number 2 that goes with this part of the working out. So our answer is negative 1 because 5 to the negative 1 is 1/5. Now the next question is interesting. It says log of 2x plus 1 is equal to log of 3x minus 2. So in this situation, it's similar to the top one, but in this case we're dealing with logs instead of or instead of natural log. So basically, what I'm going to do is, well, this is actually really important to know that if he doesn't put a base here, it's implied that the base is 10. So what I did is I just put 10 and rose everything on top of that. So 10 with an exponent that has the log in it, that's going to cancel things out because this is one of the rules that you should know about logs, that if that's touching, then it basically cancels each other out. And so I just took 10, rose everything up. That'll cancel out our logs so that we get rid of all those logs and then we can just work with our x's. So here I've crossed out the 10s and the logs, and then I have 2x plus 1 equals 3x minus 2. From here, all you have to do is solve for x. So 2x minus 3x is equal to negative 2 minus 1. And so 2x minus 3x is just negative x. And then a negative 2 minus 1 is just negative 3. And so that just means x is equal to 3. And that's it for that question.